Hi everyone. So I know that in the last video we did do a couple examples of using this function notation thing, but I definitely think this is something that you really can't get enough examples of. So let's take a look at this one. So my function machine here is the function f of x. Again, that's what those parentheses mean. It's not f times x. Not that. It's not that. It's f of x, and that equals the absolute value of 3x plus 2. Okay, so one way to think about this, and I always struggle with how best to make this as easy as possible for you. And then remember, our inputs are the x's, and the output is f of x. So like this whole thing always exists as one big object, one big symbol. Okay, so another way to kind of think about this is this function takes whatever the input is, whatever that happens to be. It could be 7, could be 6, could be whatever. And then what does it do? Well, it multiplies that input by 3, whatever that happens to be, and then it adds 2, and then it takes the absolute value of it. And so let's just take a look. So maybe I want to figure out f of, I don't know, -6, suppose, right? And so now this means, again, -6, that is simply my input. And so when I'm actually trying to figure out what this is, you give this function machine -6, you throw it in the top, and then now the little gremlins inside, they say, oh, okay, I'm going to take that input, multiply it by 3, and then add 2, and then take the absolute value of that. And so this is going to be the absolute value of 3 times -6, because then that -6 is our input. And I'm going to add 2, and then take the absolute value. So remember, absolute value is a type of grouping or type of parentheses, if you will. And so we'll do everything inside there first. So let's see, 3 times -6, that's going to be -18. Then we're going to add 2 to that. So that's going to be -18 going forward 2. That'd be at -16. And the absolute value of that is positive 16. And so the way we would do this, so let's not forget what this is. So this is f of -6. F of -6. So again, this whole thing is the output, but it also tells you what the input was. And that's what's really cool about this function notation, is that it tells you in just a couple symbols what the input was and what the output was. So in English, what this box is saying is essentially saying, when, and this is going to be kind of long, but so this is why it's helpful to use this notation. When I input x equals -6 into the function machine f of x equals the absolute value of 3x plus 2, the output that comes out, the output is 16. And so let's kind of see where this comes up in the sentence. So the function machine part, where the actual equation is, you would have to write that out. So we know that from the problem. The input, I'll do that in yellow. When I say the input was -6, that's where this -6 is inside the parentheses. Ready? That's the input right here as well. And now when we say the output, and it's cool because the output being 16 incorporates the fact that the input -6. Now I'm going to do this one in light pink, I suppose. The output is 16 is this entire box right here. Okay. So now let's try the opposite question. So I'm just going to copy this part down to make space. Oops, that's the notes from class today. So let's, again, our function machine, I guess it's in red now, f of x equals the absolute value of 3x plus 2. Again, my x's or my inputs go on the top. My outputs are the f of x. Again, those always exist. Like f of x is the output when you plug in x. Okay. I just want to try one more thing. Something kind of that I like to do to show if we really know what's going on is, what is f of let's see, what's a funny shape? I don't know, upside down triangle. So this looks weird, but if you really know what's going on, then remember all this says is the input is this upside down triangle thing. That's all I'm telling you to do. And so remember, the inputs are the x in the original equation. So wherever we see an x now, it is now upside down triangle. That's all. And so what this would mean, this would simply be whatever big upside down triangle is, triangle squared plus 2. If I want to plug in stick person, that would just be stick person squared plus 2. That's all. Okay, so let's actually now go on to another actual math example where let's pretend we're going to use the same function here. Let's suppose that f of x equals, let's see, how about 30? Okay. So this one's a little bit different because, again, x is my input, right? And I actually don't know what it is. So this question says, or the problem that is being presented to you is that, hey, the input x creates or causes an output of 30. So in this case, we know what the output is, but we don't know what the input was. Okay, so let's try to figure out what that is then. So what's the input? Or what was the input? Well, let's see. Again, since this is the output, but we know how the function machine works, and what you're essentially doing is we're going to substitute this f of x thing right here with 30. Right? Because like we said before, when we said the input, zoom in right here, when the input is upside down triangle, it just means upside down triangle squared plus 2. When the input is stick person, the output is stick person squared plus 2. And so all this says, if I said f of x equals 30, remember f of x in our example is x squared plus, no, sorry, that was from class, is absolute value of 3x plus 2. And that is 30. And so now we come about to this absolute value equation. How do I solve this? I should have actually made this one a little bit not so tricky. But if the absolute value of this inside here is 30, then the thing inside must be 30. Here's what I mean. The absolute value of 30 is equal to 30. But that's not the only number whose absolute value is 30. Right? Because here's 0. If you go 30 units to the right, then yeah, you'll end up at 30. But remember, absolute value is just the overall distance, doesn't care which direction you go. And so if I go 30 units to the left, then you're also 30 units away, but that's at negative 30. So when you have these absolute value equations, and we're going to take a quicker look or another look at this in the future, a lot of times you'll have like two possibilities. And so this would mean that the thing inside, which is 3x plus 2, 3x plus 2 has to equal 30, or 3x plus 2 equals negative 30. And now we can solve this. I'll just subtract 2 from both sides. I'm going to do this on this side as well. I'll have 3x equals 28. And over here I'll have 3x equals negative 32. And then we'll divide by 3. And I'll have 2 inputs now. So this means that x could equal 28 over 3, or it could equal negative 32 over 3. And so what we could say then is that f of 28 thirds equals 30, and f of negative 32 thirds equals 30 as well. So this is a case where two different inputs could create the same output, which is totally possible. Okay, so sorry this one example got a little bit more interesting than I initially anticipated, so that's my bad for that. But hopefully this video helps clear up a little bit about how to read and how to use this function notation. Alright, thanks for watching.